Did you know that according to physicists, we are actually moving into the future? You heard that right. According to our best current understanding of physics, time only moves forward. And this has got a lot of people thinking about, what does it mean to be alive? How do we make sense of being conscious and self-aware in a universe that's just running down? To unpack this, let's look at the universe's directionality. You probably already have a pretty good idea of how the universe works. Things exist and then they interact. It seems simple enough, but it turns out that's actually all there is. All the changes that happen in the universe. Everything you see and touch, hear and smell, taste and feel, all of it is the result of things interacting. But here's the thing. Some of those interactions can't happen in reverse. When you drop something, it falls to the ground, but you never see it unfall. I mean, you don't notice it because it doesn't happen. If you put toothpaste back in the tube, it's gone for good. Even if you stirred it around a bunch, you can't get it unmixed. That's because some things are irreversible. And it turns out that's because of the nature of the universe itself. According to the second law of thermodynamics, the entropy of a closed system will always increase over time. Let me break that down for you. A system is anything that you're interested in studying, like a cup of coffee. Entropy is a measure of the number of ways that the components of the system can be arranged without changing the overall properties of the system. Now, you're probably wondering, well, what does that mean? Well, it means that if you have a cup of coffee, there are many ways to arrange the coffee molecules in the cup. You can arrange them all in a line, or in a circle, or in a triangle. And no matter how you arrange them, it's still a cup of coffee. So, the entropy of a cup of coffee is high. Now imagine that you have 2 cups of coffee, one hot and one cold. If the cups aren't interacting, then the entropy of the system is still high. But if the cups start to interact, then new arrangements become possible. Now, some arrangements are more likely than others. Imagine you have 6 hot coffee molecules and 1 cold coffee molecule. It is far more likely that the arrangement of 6 hot and 1 cold is going to stay that way than it is that suddenly 5 of the molecules are cold and 1 is hot. In fact, if you think about it, it's impossible that the 5 molecules suddenly become cold and 1 becomes hot. The reason for that is because it would take a very specific arrangement of the molecules for that to happen. And there are a lot fewer ways to arrange the molecules so that 5 are cold and 1 is hot than there are to arrange them so that all 6 are hot and 1 is cold. So the hot and cold coffee are likely to stay that way until the cups eventually reach thermal equilibrium. And once they reach thermal equilibrium, there are just as many ways to arrange the molecules as there are ways to arrange the components of any other system. When that happens, the entropy of the system reaches maximum disorder and it can't increase anymore. And that, dear viewer, is where things get interesting. You see, the entropy of the entire universe is currently increasing. But according to the conservation of entropy, the entropy of the universe must always increase, because that is how we define the entropy of the universe. So that means that everything in the universe is constantly moving toward maximum disorder. But hold on a second. You've probably noticed that your room doesn't tend to spontaneously clean itself. So how does everything in the universe move toward maximum disorder? Well, that's a great question, and it's a really important one. Because it turns out that this movement toward maximum disorder is why time marches only forward. That's because when the entropy of a system reaches a maximum, it's at an equilibrium. And when a system is at equilibrium, nothing changes. Remember, all of the changes that happen in the universe are caused by interactions between things. So if everything's staying in one place, then nothing changes. But if things are interacting, then some arrangements become more likely than others. And those more likely arrangements are the ones that lead to maximum disorder, the ones that increase entropy. So it turns out that when the entropy of the universe increases, everything in the universe moves toward maximum disorder, and that is why time moves forward. But wait, now that we understand why time moves forward, does that mean that time travel is impossible? Well, yes. But also, no. That's because while the entropy of the entire universe is increasing, entropy only applies to individual systems. For example, sure, the entropy of your room is increasing, but that doesn't mean that the entropy of the entire universe is increasing. And you can actually decrease the entropy of a system, you just need to pay for it somehow. For example, you can decrease the entropy of your room by cleaning it, but you have to pay for it by expending some of your own energy, which ultimately comes from the food you eat, which has lower entropy than the waste you produce. Now, you might be thinking, well, what if I could somehow use the energy that's in the waste to clean my room? And to that I say, that's pretty clever, but it won't work. That's because for every action, there is an equal and opposite reaction. And it turns out that the total entropy of the universe is always increasing. So even if you cleaned your room, the entropy of the entire universe would still increase. That's because you have to do something to clean your room. And that means that there's some change in the universe. And when there's a change in the universe, there's an equal and opposite reaction somewhere else. Maybe your mom is getting a headache, because now she wishes you'd spend less time watching YouTube videos and more time doing your calculus homework. So sure, you can decrease the entropy of your room, but the entropy of the universe will still increase. So that means that yes, time travel is impossible because the entropy of the entire universe is increasing, but it also means that entropy only applies to individual systems, which means that you could decrease the entropy of a system if you paid for it. That's why scientists believe that negative entropy is possible, but it's just really rare because it's hard to pay for. So there you have it. We are moving into the future because the entropy of the universe is always increasing. But if you want to learn more about how the world works, don't stop there. Thanks for watching.